Hello everyone, welcome to virtual learning session of BCS12. In this session we shall discuss the solution of the most important application of this unit is how to solve the system of the linear equation, rather they are homogeneous and the non-homogeneous. Let us start. First of all, we see what is a determinant. A determinant, it is a square array of the numbers symbolizing the sum of the certain product of these numbers. This definition will be much more clear while we will practicing the numerical problems. Every determinant can be written in this form. Say, we denote it by letter delta and write the elements between the two lines. Say, it is 1, 2, minus 1, 0. It is a formation of the determinant in which different numbers are arranged in a certain order. These are rows. Here, row R1, it is row R2, it is called column C1, it is column C2. One thing is clear, a determinant is always a square array of the numbers. Two rows, two columns, or there are three rows or three columns like this. 1, 2, 3. It has order 3 and it has order 2. This determinant has the order 2 and this determinant has the order 3. It means a determinant with the n rows and the n columns has the order n, and we can write a general determinant in this form. Delta is equal to a ij of order n. I represents row and j represents the number of the columns. This element we can write a11. It is the member of the first row, first column, member of the first row, second column, second row, first column, second row, second column. So we can write here it is an aij with order 2. So we shall in this topic discuss only the determinants of order 2 and 3. Their application is very helpful in solving the problems in mathematics, in physics, even in the chemistry and the physics. So let us discuss about the solution of these determinants, how to solve a determinant. Then we start with a 2 by 2 determinant, how to solve it, then 3 by 3. Let us take an example. Delta is equal to 1, 2, minus 1 and 3. It is very simple process like this. Multiply this element by this and delta is equal to 1 into 3. Then from bottom to top. When we travel from bottom to top, we apply a sign, negative sign from our pocket. It means minus plus 1 into 2, 3 plus 2, that is equal to 5. That's how we can solve a 2 by 2 determinant in a simple process. Every determinant have certain value. There is a difference in solving an order of 2 matrix determinant and an order of 3 determinant. Now let us check how to solve a determinant of order 3. Let us take an example. Say it is 1, minus 2, 3, 2, 1, 2, 3, minus 4 and 0. It is determinant of order 3. 3 rows and the 3 columns. when we solve a determinant of order 3, we keep in mind certain rules. Here we write on the side these signs plus, minus, plus, minus, plus, minus, plus, minus and plus. It is 3 by 3. It is also a 3 by 3 rule. We superimpose this rule on the signs of these elements. Then how to solve this determinant? We write delta is equal to, we start with, say, draw a vertical line, then a horizontal line. This member we write outside the brackets, then these numbers which are trapped into these lines, we write them separately, -4 and 0. Its sign is plus, here sign is plus, plus into plus, we write the sign plus. Then draw another line, trap the second column. Now see, this element is trapped. Its sign is negative. Rule says negative. Negative into negative, that is positive. And the elements which are out of the trap, they are 2, 3, 2, 0. Then remove the first line. Remove the first line. Now see, this element is out of the trap. It's 3. Its sign is plus. Its sign is plus. Plus into plus, plus, and the element is 3. No. Which elements are trapped? They are 2, 3, 1 and -4. 2, 3, 1 and -4. This 3 by 3 determinant is reduced into 3 2 by 2 determinants, and we can solve it as previously. 1 into 0, that is equal to 0. From bottom to top, we apply a minus sign from our pocket. Minus minus plus, plus 8, plus 2, 2 into 0, 0, 3 into 6, minus from the pocket, -6, plus 3, 2 into -4, -8, 3 into 1, minus from the pocket, it's -3. That is, no. Open the brackets, expand them, it is 8, -12, -11 into 3, -33. That is 8 minus 45, that is equal to -37. It is the value of a determinant. It's very important for the determinants. We can solve them. It is their peculiar property of a determinant. That is why it is much more helpful in the different fields of the math and the science. We can convert any engineering, mathematics, physics problem into the determinants and then can solve them with the help of the linear equation that we shall discuss later on in this topic. It was the introduction for the determinants, how to represent them and how to solve them. Now further we see what are the minors and the cofactors. The terms which we are using, they are also useful for the next unit which we shall discuss in the matrices. But we shall take the introduction of these definitions. Rather, they are not too much important in this unit, but it will help us to solve the matrices into the block in this unit 2. What are the minors and the cofactors and how to find them in a determinant? Let us see. Let's take an example. We shall discuss how to find the minors and the cofactors of the determinant. First we start with a determinant of order 2. Let us take an example. Say it is in determinant 2, -1, 3 and 5. No. Our objective is to find the minors. First of all, we see what is a minor. If delta is a determinant, then Mij is the minor of the element Aij. These numbers, we call them either elements or the members of an determinant. It is the minor. Then what is a cofactor? A cofactor is simply, we denote it by either capital letter or small. Aij is equal to -1 raised to the power I plus j into mij. I means the number of row of an element and j means the number of the column of the element. Simultaneously, we shall discuss about minors and the cofactors. Rather, these cofactors, they are very important for us to solve the matrices, particularly when we have to find the inverse of a matrix. Let us see. Mark them. It is A11, A12, first row, first column, first row, second column. A22, it is member second row, second column. It represents second row, first column, and second row, second column. First of all, we see the minor of A11. Say we write M11. In this way, divide the determinants in this way. No, minor of 2 is 5. Minor of 2, M11, its name of element is 2 and it has the minor 5. Then next element M12, it is -1 and it has minor 3. Simply we cross the element. 2 has minor 5, -1 has the minor 3. Then M21, it is 3 and it has minor -1. This in front of this. Then M22, this element is 5, it has minor 2. 4 elements of determinants and there are the 4 minors. And then how to find out the cofactors? Cofactor means -1 raised to the power I plus j into mij. Let us see A11. A11 is 2. It means cofactor of the element 2. We write -1 raised to the power I plus j. Here I stands. This member belongs to first row and the first column. 1 plus 1 into what is its minor? 5. It means that is equal to -1 square, again equal to 5. Then A12. A12 means -1. Now we write rule -1 raised to the power 1, I1, J2 and its minor is 3 into 3. That is equal to -1 raised to the power 3 into 3 and that is equal to -3. Then A21 element is 3. Here rule is -1 raised to the power I plus j raised to the power 2 plus 1 into its minor. Minor is -1 and that is equal to +1. -1 raised to the power 3, -1 minus into minus, that is +1. Then A22 element is 5. It is -1 raised to the power I2 j2 into its minor is 2. That is equal to 2. In this way, we can find the minors and the cofactors of the elements in the case of a 2 by 2 determinants. Now, we check this rule in a 3 by 3 determinant. Let us take an example of a order 3 determinant and then find its minors and the cofactors. So delta, say 1, -1, 0, 2, 3, -4, 2, 1 and 5. It is determinant of order 3 by 3. We mark their designation A1, A12, A13, A21, A22, A23, A31, A32, A33. This fix denotes this member is from the third row and the second column. Now we find the minor for A11. M11, its element is 1. But it is totally different from, the calculation is totally different from a 2 by 2 order determinant. Here we will have to find out the corresponding elements. In this way, cross the 1 like this. 1 is outside the crossing. We have to find the minor of M11. Then the elements which are out of crossing, they are 3, 1, minus 4 and 5. And we can calculate it like it is a determinant 15 plus 4, that is equal to 19. Like this, minus from the pocket from bottom to top. Then M12, here M12 is minus 1. So draw again one more line. Minus 1 is out of this trap. No, elements trapped are 2, 2, minus 4 and 5. And we solve it like a determinant which is 2 by 2 order. It is 10 plus 8 is equal to 18. Then comes third element, first row, third column. It is 0. 0 does not mean it has no minor or the cofactor. 0 also has certain values in form of minors or the cofactors. Remove the first line. No, the remaining elements, these are 2, 3, 2, 1. That is equal to 2 minus 6 is equal to minus 4. Now the process for the first row is complete. Remove these lines. Now we are doing for second row. Trap the second row in this way. Then draw this line so that first column is outside the trap. This element is 2. It is M21. Its name is 2. And elements out of crossing are 3, minus 4, 1, 5. That is equal to 15 plus 4 is equal to 19. Same rule we are following when we multiply this 3 by 5, 15, and when we travel from bottom to top, we give a negative sign from our pocket. Then next element is M22, second row, second column. It is 3. For this, we draw another line like this. Trap. 3, no. Elements out of trap are, they are 1, 0, 2, 5. Evaluate them. It is 5 minus 0, that is equal to 5. Then M23, element of second row, third column. It is minus 4.
Sir,
that is equal to,
बिल्कुल सामने आ रखे हो.
that is equal to minus 4.
दोबारा से ये वाला ना M वाला दोबारा बोलना.
ये. Let us see. Next element is M23. The name of element is minus 4. For this, we remove the first line. Remove the first line. Now see, the elements which are out of trap, they are 1, minus 1, 2 and 1. Evaluate them. 1 plus 2, that is equal to 3. Now the process for the second row is complete. We start with the third row. Remove all the lines like this. Here it is the third row. Trap this row in this way. Draw this line. Then remove the first column. No, it is the first member. It is, name is M31 and it is 2. The elements, they are -1, 0, 3, -4. That is equal to 4 minus 0, that is equal to 4. Next element is M3, 2. M3, 2, member of the third row and the second column. It is 1. Trap it, draw another line. No, it is out of trap, and the trapped elements are 1, 2, 1, 2, 0, 4. Evaluate them. That is 4 minus 0 is equal to 0. Then last element, it is member, name is member of the third row and the third column, and it is value is 5. How to find its corresponding elements? Again, remove the first line. Remove the first line. Now see, they are clear the elements which are out of trap. They are 1, 2, -1, 3. Evaluate them. It is 3 plus 2 is equal to 5. That's how we find the -4 a 3 by 3 determinant. That's all for this. Thank you.